Hello, class. We are going to be starting chapter 4, starting section 4.1 here in the Trig class. Chapter 4, in my opinion, is challenging. Chapters 4 and 5 are quite challenging. And this will be, for most of you, the first introduction to this idea of proofs. And for those of you heading into a lot of math, you will have to do a lot of proofs. Practicality wise, I'm going to be bluntly honest, not the most practical of the math ideas that we learn. But when you are systematically working through a problem, that's kind of what we want to outline in this chapter. And as the sections get deeper, the problems get a little bit harder. So we're going to start in section 4.1 and introduce a bunch of these trig identities, and we're going to show how to prove one equation equals the other side of an equation in a proof format. And so let's get started here in the slides. And so here we go in section 4.1. And I think this simplifying trig expressions is actually harder than proving trig identities. You'll see that when you prove identities, you actually know what the answer is. You just have to get there. But simplifying, it's like, well, what's the right answer, right? So you can keep going. So, but I think that it gets you started thinking about the process. So I do want to warn you that you will need a cheat sheet of all these approved, what they're called trig identities that are used throughout this chapter. The one that says the right triangle identities are very useful. And so I would recommend having that handy on your computer. I printed it out when we were back at Harold, Washington. So if you don't have a printer, I get that. So we're going to continue to just start introducing these. We did a little bit of introduction when we talked about those Pythagorean identities. And so these are the ideas that we've introduced so far. This idea of the reciprocal identities where, cosecant 1 over sine, et cetera, et cetera. We talked about the Pythagorean identities. Those are probably the most important. And by far, the most important is sine squared plus cosine squared equals 1. I actually use that in simplifying some equations in my engineering life, but none of these other ones, to be honest with you. Odd evens come in handy as well. And this cofunction, meaning sine and cosine are the same function, but just 90 degrees phase shifted from one another. And you can see the other ones are the same as well. And so manned with this type of information, let's walk through a couple examples and kind of a step-by-step process on how this works. And so I could show you on the slides, but I think what would be better is I'll walk through a couple of these examples here on the whiteboard and kind of walk you through these techniques. And the techniques are algebraic and trig concepts built into one. So say like we had this equation, cosine of x plus tan of x sine of x. And it says simplify. And you look at that and say, what can I do with that, right? Well, my strategy always is if you're not sure what to do, put everything in the sines and cosines, and you'll find that that'll be a useful technique. And so you remember that this would be the reciprocal identity where tan equals sine over cosine. And it's important, oops, not an x. And it's important to track each one of your steps this way. If you don't do it this way, it's technically not correct. So I'm going to try to be pretty diligent in showing you. So this is sine of x over cosine of x times sine of x. So we did that substitution. So the next step is that what we have here, right, is cosine of x. And this is just algebra, so you don't really have to put something here. This would be sine squared of x, all right? Sine times sine is sine squared over cosine. So the algebra, you really don't have to state exactly what you're doing with regard to that. It's finding a, so the next step is let's find a common denominator. When you have a fraction, that usually is useful. So this would be the common denominator. And so in this aspect, the common denominator is cosine of x. So what happens here? Well, cosine of x squared over cosine of x equals cosine, right? So that's the first term. And so we have plus sine of x squared. So now with the Pythagorean identity, all right? And again, you have to indicate what you're doing here. The idea is cosine squared plus sine squared equals the number one, as I said, one of the more important identities. And so in my life, I would leave this as the simple way because I always tried to use sine and cosines. But if you do that reciprocal, you would see that this is the reciprocal identity. And it ends up being secant of x. Excuse me, a little dry there. So one of the questions I get from students all the time, do I have to note each one of these steps? And the answer is yes. That is the appropriate way to do this instead of just writing everything and just keep going. And so this is the proper technique for proving things. And so what are you doing is what you actually have to state. So there's one example. Let's do another one. So let's try this one. Sine x cosine squared of x minus sine of x. And I think the hardest thing is what do you do first, right? Well, you look at this and it's like you have a cosine squared, right? And you have the sine of x is in both factors, right? Sine of x in first, sine of x in the second. So what I would do is factor out the sine of x. When you factor that out, you get -1. So that's a factor. Technically, you don't have to write down all your algebraic steps. It's just the substitution steps that is technically required to show what you're doing and just randomly plugging stuff in, right? So what would be the next step? Well, when you see cosine or sine squared and a 1 there, it always brings this up, right? Sine squared of x plus cosine squared of x equals 1. So if you think about it, if I brought, whoops, wrong one. If I brought cosine to the other side of the equation, what does this look like? 1 minus cosine squared of x. And you want to kind of do that substitution with the cosine squared minus 1. And so what is the relationship between those two? You could see that they're inverses, i.e., they're negations of one another is a better word, excuse me. So if you multiply everything by -1, what ends up happening? Or, excuse me, not multiply. Factor out a -1. So if you take a -1 out of here, what ends up happening? Well, the minus comes out, all right? And basically you flip these. So now it ends up being 1 minus cosine squared of x. And look how that works. And this technique is used a lot, so I'm glad we're bringing this up. See, if I bring this minus back in, it changes this to a -1. Bring this minus back in, and it changes it to plus cosine squared. And now we could use the Pythagorean identity. And that's the one you're going to be using the most, so get used to it. And so that implies sine squared of x, right? So now you can multiply everything together here and you would get sine cubed of x. Okay, so here starting to think about what we're doing in some of these identities. And so again, I do want to point out that this is going to come in really handy. So have it handy with you. And so that's simplifying trig functions, which is very similar to proving trig identities, which is what we're going to introduce next. So I'm going to end this lecture and finish section 4.1 in the next lecture.